Let us begin our discussion of section 1.5, population models. Here's what we do here. Let P of t denote the population of a given species at time t, and let R of Tp denote the difference between its birth rate and its death rate. If this population is isolated, then dp dt, the rate of change of the population, equals Rp of t. In the most simplistic model, we assume that R is constant. That is, it does not change with either time or population. So we have the following equation. It's written dp dt equals Rpt. R is a constant. Let us replace R by A. We come up with the following equation, this one. Now, if the population of the given species is P0 at time t0, then P of t satisfies the initial value problem, this one. And now, how do we solve this initial value problem? Well, we go back to section 1.2. Note that what is written here is of this form. To see it better, let us rewrite this equation in the standard form. In order to do that, let us move this to the left. Done. And let us rewrite this portion as plus negative a times p of t. Now note that what is written here is in this standard form. In our case, a of t is equal to negative a. The solution of this initial value problem is written over here. So let us copy. P of t is equal to P0, this P0, times e to the following power, negative integral from t0 to t. T0 is over here. And then inside the integral, we have this, negative a. Negative times negative is positive. And then antiderivative of a, remember a is a constant. Antiderivative of a is a times s. And then we replace s first by t. Then by t0, we find the difference. The result is this. P of t is equal to P0 times e to the following power, a times t minus t0. Folks, any questions here?
PT would equals 2y on the other one, right?
Yes. P of t plays the role of y over here. Absolutely.
Thank you.
Any other questions?
Where did the s come from?
Well, remember, since t is already taken inside the integral, instead of t, we should use some other letter. For example, s. So here, p of t, here we have t, therefore inside the integral, we use, for example, s. Was that your question?
Yes, thank you.
Any other questions?
Well, will there ever be cases where we won't be given a point?
Well, both points should be given. T0 should be given and P0 should be given. That's the whole point about the initial value problem. Any other questions?
The a in the equation is essentially just r, but we're saying that's constant, so the a would still represent the difference in the birth rate and the death rate. It's just held at a constant rate. correct.
Yes, so here it says, let us consider the most simplistic model when R of Tp is a constant. Let us denote this constant by A. That's it. So this is a very simplistic model. This function of two variables is a constant function.
Okay, thank you.
Now let us discuss an example. Let P of T denote the human population of the Earth at time T. It was estimated that the Earth human population was increasing at an average rate of 2% per year during this period. Let us start in the middle of this decade on January 1st, 1965, at which time the US Department of Commerce estimated the Earth's population to be 3.34 billion people. So we come up with the following model. In our case, T0 is 1965, P0 is this, 3.34 times 10 to 9th power. And since an average rate is 2%, A is equal to 0.02. So the formula for P is over here. This is P0, this is T0, this is A. Next step, let us see how is this formula accurate. One way of checking the accuracy of this formula is to compute the time required for the population of the Earth to double. Well, to double means this is equal to 2 times P0. If this is equal to 2 times P0, we can cancel out P0, and in our particular case, we'll get the following. This portion, which is over here, let us replace this by capital T, is equal to 2. We ln both sides, we get this, and then we divide ln of 2 by 0.02. The result is the following, approximately 34.6 years. So, in approximately 35 years, according to this formula, the population doubles. Is this true? Population in 2000. Well, it's written 6 billion. It's different from 3.34 times 2, which is 6.68. Let us see when it doubled. Let me put here 7. Well, it's approximately 2007, 2008. So the exact number is approximately 42, 43 years. But according to this formula, it's approximately 35 years. Still pretty good estimate. Folks, any questions here?
Professor?
Yes?
Where did you get the 0.02t from?
Over here, if we replace T minus 1965 by capital T, we obtain exactly what is written here.
And why are you doing that?
Excuse me?
And why are you doing that?
Well, why not? Let us denote this by capital T. So, if lowercase t is 2000, this difference is indeed 35.
Okay, I see. The difference you're just saying is t.
Yes.
Yeah, I have one more question.
Yes.
Right. So for the same example, let's say let's say it gave you the birth rate, right? And it also gave you the death rate. In that case, then, in order to figure out your A value, would it just be your birth minus your death rate?
Yes, absolutely.
Okay,
For example, if birth rate is 2% and death rate is 2%, the average rate is 0.
cool. Okay, awesome. Thank you.
It's exactly, by the way, what is written here. You know the difference between its birth rate and its death rate. In our case, this is A. Any other questions?
So how would we, let's say like the population quadrupled, what we do, we'd set like the E.02t to 4?
Yes. So instead of 2, we put 4.
Okay, so it's just like essentially just putting the number that we're looking for.
Well, once again, the way we come up with this is the following. Double means population is equal to 2 times P0. So this is equal to 2 times P0. And now after the cancellation of P0, we get the following. E to this power is equal to 2. This is how we come up with this formula. Does this make
Yeah,
sense?
that cleared up a lot. Yeah.
Any other questions?
Did you know that you were looking for the number to be 35? Or did you just solve for it and you got 35?
Well, here we put 35 because t is approximately 34.6. 34.6 is approximately 35. This is what this formula gives us. This formula tells us that the population will double in approximately 35 years. However, the actual number is approximately 42, 43 years. Was that the question?
Yeah, I think.
Now, bigger t, less accurate is this formula. Please take a look at this. If t is 2515, the formula gives us this. It's not 2 billion or 3 billion. It's 200,000 billion. Of course, it cannot be. So, this model gives us pretty good estimates if t is relatively small. Here's another example. Over here, a small rodent reproduces very rapidly. We take the unit of time to be a month, and assuming that the population is increasing at the rate of 40% per month, if there are 2 rodents present initially at time t is equal to 0, the initial value problem is this. So once again, P of 0 is 2 according to what is written here, and A is 0.4 according to what is written here. Now, the solution of this problem is over here.
I have one quick question.
Yes.
Why is it e to the negative or e to the 0.04t instead of e to the 0.4t?
Yes. So this is an esprit. Instead of 0.04 should be 0.4. Thank you.
Okay, thank you. Yeah.
And now let us compare observed values with calculated values for t is equal to 0, 2, 6, and 10. You can see that these numbers are actually pretty close. So for small values of t, our model gives us pretty good estimates. However, if t is big, the numbers that our model gives us are unrealistic. So question is how to fix it. And here is an idea. So number 1, when the population gets extremely large, the above model cannot be very accurate, since it does not reflect the fact that the individual members are now competing with each other for the limited living space, natural resources, and food available. How do we adjust the model? We must add a competition term to our linear differential equation. A suitable choice of a competition term is negative b p squared, where b is a constant, since the statistical average of the number of encounters of two members per unit time is proportional to p squared. So the new model is p prime is equal to ap minus bp squared. Observe that if b is equal to 0, we go back to the model that we just discussed. In general, the constant b will be very small compared to a, so that if p is not too large, then the term negative bp squared will be negligible compared to ap, and the population will grow exponentially. However, when p is very large, this term negative bp squared is no longer negligible and thus serves to slow down the rapid rate of increase of the population. So the new initial value problem is now this: dp dt is equal to ap minus bp squared, and p of t0 is equal to p0. Question is, how do we solve this initial value problem? Note that the previous initial value problem was easy to solve because this is fundamentally same as this. The equation is first order linear differential equation, moreover homogeneous, according to what is written here. But the new equation is no longer linear because here we have p squared. What do we do? All right, we cannot apply this formula. However, in order to solve this initial value problem, we can use the separation of variables method. Here's how we do it. Let us copy this over here, and then let us move this term down to the left, and let us move dt to the right. Done. We just separated the variables. All p terms are on the left, and the t term is on the right. Here's what we do next. We integrate both sides. We integrate the left-hand side from p0 to p, and we integrate the right-hand side from t0 to t. It is easy to find the right-hand side. By the way, you might ask me a question, why all of a sudden instead of t we have ds? Because t is taken. Therefore, inside the integral, we have to use a different letter. Now, there is nothing inside this integral. Means we have 1, the number 1. Antiderivative of 1 by s is s. And then plug in t instead of s, plug in t0 instead of s, and find the difference. So this is equal to t minus t0. Big question is, how do we find this integral? We are about to discuss it. Now questions.
Yes, Professor. Why is p squared when it's multiplied by b?
Yeah, so it's not so easy to explain. We just give you a pretty small piece of information. B is a constant since the statistical average of the number of encounters of two members per unit time is proportional to p squared. Proportional means p squared times b. So by statistics.
Oh, okay, so it's given in the question, actually.
Well, yes. So the equation is this.
Thank you.
Instead of p prime is equal to ap, we have p prime is equal to ap minus bp squared. Was that your question?
Yes, thank you.
All right, next. So how do we find this integral? Folks, the method is called partial fractions. We go back to my Calculus 1 website. Here is this topic. Please take a look first at this intra-level example number 1. Find this integral. Here's what we do. By college algebra, this is equal to 1 over x minus 1 over x plus 1. And then the rest is easy. Our initial integral is equal to integral of 1 over x minus 1 over x plus 1. Antiderivative of this is ln of absolute value of x. Antiderivative of this is ln of absolute value of x plus 1, and the result follows. So the key idea is to rewrite the expression inside our integral as the sum or the difference of elementary fractions. Please take a look at this. First, we factor the bottom and rewrite this as the sum of two elementary fractions, which are easy to integrate. In our case, let us first factor the bottom. Done. And then let us try to find two constants, capital A and capital B, such that this is identically equal to this. Like in this case, capital A is 1, capital B is -1. In example number 2, capital A is 1/2, capital B is 1/2. So once again, for which capital A and capital B, this is identically equal to this. How do we find A and B? Well, here's what we do. Let us start from here. It's over here. If we multiply top and bottom of this fraction by A minus BR, and if we multiply top and bottom of this fraction by R, and then put together these two fractions with the same denominator, we will get this. Next step, expand parentheses, done. Then for convenience, let us switch positions of term number 2 and term number 3, done. Lastly, factor out the common term R, done. So, note that these two fractions have the same denominator. It's same. Therefore, this and therefore this is identically equal to this if and only if one is identically equal to this. It's exactly what we have over here. Next question is, for which capital A and capital B the left-hand side is identically equal to 1? Is the answer. Know that if B minus BA is equal to 0, and if this is equal to 1, On the left-hand side, we get 1 plus 0 times r, and 1 plus 0 times r is 1. So, if we find capital A and capital B such that this is 1 and this is 0, problem is solved. And now, here's what we do next. According to what is written here, capital A is 1 over lowercase a. According to what is written here, if you move BA to the right, capital B is BA, but A is 1 over lowercase a. Replace this by this, you get B over A. So, if capital A is 1 over A and capital B is B over A, this is identically equal to this. Folks, let me stop over here. Think about questions.
Can you go back to your Calc 1 website?
Yes. Over here.
Yes, for example 1.
Yes.
How do you know that it's 1 over x minus 1 over x plus 1?
Yes, so very good point. Here we just play with algebraic expressions and conclude that indeed this is equal to this. 1 over x minus 1 over x plus 1 is identically equal to this. Because if you find a common denominator, if you multiply top and bottom here by x plus 1 and top and bottom here by x, on the top you will get x plus 1 minus x, which is indeed 1. The question is how to find such an identity. And in order to find such an identity, we use this technique. For example, somewhere over here, I think I have a relatively simple example. Let me take a look. I think it's this. Yeah. So factor this, done. And then in order to find capital A and capital B, we rewrite this as this. And now 1 is supposed to be equal to capital A x plus 2 plus capital B x minus 1. And then there are two ways to come up with A and B. In our case, A is 1/3, B is negative 1/3. Was that your question?
Yes, thank you.
Okay, now let us continue. So, we just realized that the fraction 1 divided by r times a minus br is identically equal to this, where a is 1 over a, b is b over a. Here's what we do next. First, let us factor out the common term, which is 1 over a. Done. And then, integral of 1 over r is equal to this, and integral of b over a minus br is equal to this. Why is that? Let us look at the appendix over here. So, first of all, let me show you why integral of 1 over r is equal to ln of p divided by p0. Here is this integral. Antiderivative of 1 over r is ln of absolute value of r, but r is non-negative because r is population. Population cannot be negative. So we remove absolute value, it's just ln of r. Then we plug in p, we plug in p0, find the difference, and we know that the difference of logarithms is logarithm of the quotients. It's exactly how we jump from here to here. Next step, how do we integrate this function? It's over here. We use u substitution. Let us denote a minus br, which is over here by u. We put g from the left and g from the right. A is a constant. Derivative of a constant is 0. Negative b is a constant. Therefore, derivative of negative br is negative b. Now, there is no negative here. Therefore, we multiply both sides by -1. We get this. Now, let us get rid of our terms. We replace bdr, which is over here, by negative, which is over here, du, which is over here. And then we replace a minus br by u. We get 1 over u. Lastly, since here we have integral from p0 to p, we have to change this number and this number. Note that r is gone. We have u, and u is equal to this. Since u is equal to this, if r is equal to p0, u is equal to a minus b times p0. It's exactly what we have here. Similarly, if r is equal to p, u is equal to a minus bp. It's exactly what we have here. Next step, antiderivative of 1 over u is ln of absolute value of u. We replace u by this. Done. We replace u by this. Done. Lastly, since we have minus in front of the whole thing, here we have minus, but here we have plus. And now we can think about what is written here as ln minus this ln. So what is written here is the difference of two ln's. This minus this. And we know that the difference of logarithms is logarithm of the quotients. So it's ln of this, which is over here, divided by this, which is over here. It's exactly how we come up with this answer. Folks, any questions here?
How come r becomes the p?
Well, note that here r is between p0 and p. So if r is from p0, u is from a minus b p0. U is from a minus b p0. Was that your question?
Mm-hmm.
Next. So, we know how we jump from here to here. Next step. The sum of logarithms is logarithm of the product. This times this. It's exactly what we have here. Next step. So, this integral is equal to this expression. But let us go back. Note that this integral, which is exactly what is written here, is equal to t minus t0. So this expression is equal to t minus t0. And if we multiply both sides by a, 1 over a disappears from here, we get this, and a appears over here. We get a times t minus t0. Now, what is written here gives us the solution of our initial value problem. Basically, the problem is solved. However, next question is it possible to write the solution of our initial value problem in an explicit way, as p of t is equal to some expression? This is an implicit way to write down the solution because we have P here, we have ln, and so on. Is it possible to rewrite this in an explicit way? The answer is yes, but this is again a step-by-step process. So, number one, in exercise 1 from homework, we show that this expression is always positive. By the way, here we remind our readers that P0 is a number, but P is a function. So this is fundamentally same as this. We just replace P by P of T. P is a function. In exercise 1, we show that this is always positive. Therefore, we can skip absolute value. Done. Next step. Let us raise E to the left-hand side and to the right-hand side. E to the left-hand side is over here. E to the right-hand side is the following. E to the power ln of da da da. But remember, ln kills E. So E to this power is just this expression. It's exactly what we have here. Next step. Let us move the denominator, the product of the denominators, to the left. Done. Then we expand these parentheses. Done. After that, move this second term to the right and switch positions. If we move this to the right and switch positions, we'll get this on the left, and this term will be on the right. Here's why we do it. Note that now on the left, we have both P terms. On the right, there is no P anymore. Next step. P is a common term. Factor it out. And lastly, divide both sides by the expression in front of P. We get this. Here is an explicit formula for P. The goal is achieved. We just simplify a little bit. If we divide top and bottom by E to A times T minus T0, we get this. So E completely disappears from the top. E completely disappears from this. What is left is just B times P0. And then E appears over here, but the exponent is negative since we divide top and bottom by this. So P of T is equal to this. Folks, any questions?
Could you please explain again how you got rid of E, the E term on the numerator of the equation?
Are you talking about how we jump from here to here?
Yes.
Sure. So let us divide the top and the bottom by this, by the E term. If we divide the top by the E term, this term disappears from the top. What is left is AP0. It's exactly what is written here. If we divide the bottom by the E term, the E term disappears from here completely. What is left is this. It's over here. But then be careful. If we divide this by the E term, it's equivalent to the following. This times this. But instead of A times T minus T0, we have negative A T times T0.
I understand now. Thank you.
Sure. Other questions?
Can you go to the part where everything gets an E term?
Are you talking about this?
And then down a couple steps.
Over here?
Yeah. Why now? Why'd we do that after that step?
So the reason is the following. We want to solve this for P. But P is here and P is here. We want to group P terms together. In order to do that, first let us get rid of these two fractions, moving the product of the denominators to the left. Done. Still we have P here and P here. What do we do next? Well, let us expand parentheses. Done. And now, indeed, we can group both P terms together. Done here. Now, since both P terms are together and there is no P here, we can factor out P. Now, over here we have two P terms. Over here we have just one P term. And if we divide both sides by this, we get an explicit formula. Goal is achieved. Was that your question?
Yes, thank you. And then the next step is just like to clean it up. We divided everything by the e raised to that a times t minus t naught.
Exactly. Instead of two t terms, we have just one t term. There is no t here, there is no t here, there is no t here. We have t only over here. Did I answer your question?
Yes, thank you.
Okay. Here is what we do next. This formula is not easy to understand. It's not a simple formula. So, can we come up with some general ideas? What does this formula mean? Fortunately, the answer is yes. Let us come up with some observations. Observation number one. If t goes to infinity, the whole thing approaches a over b. Here is why. Please take a look at this term. If t is growing in positive direction without bounds, t minus t0 is growing without bounds. But if we multiply a huge number, a huge positive number, by negative a, the whole thing becomes a huge negative number. And now we raise e to a huge negative number. Think about, for example, e to negative 100 power. E to negative 100 power can be rewritten as 1 divided by e to positive 100. But e to positive 100 is huge. When we divide 1 by a huge number, the result is a number which is very close to 0. Conclusion: if t goes to infinity, e to this power goes to 0. But if this goes to 0, the whole product goes to 0. But if the whole product goes to 0, this fraction goes to top, which is over here, over bp0, which is over here. And after the cancellation of p0, we get a over b. We came up with the following very important conclusion. Regardless of its initial value, the population always approaches the limiting value, a divided by b. Folks, any questions here?
Can you explain how it becomes 0 again, like the a minus bp 0? Like I understand, like it's the limit, but I just don't
Once
understand.
again, let us discuss. Let us do it together, okay? So t goes to infinity. Think about t as about a huge number. If t is huge, t minus t0 is huge. Agree?
Yes.
Now, if we multiply a huge number, a huge positive number by negative a is a negative number. Negative number times huge positive number is huge negative number, all right?
Yes.
So if t goes to infinity,
Mm-hmm.
negative a times t minus t0 goes to negative infinity. You agree with that?
Yes.
And now think about the exponent as about, say, negative 100. Could you please tell me e to the power negative 100? What can you say about this number? This number is big, small, it's what?
Small.
It's small, it's close to zero, right? Because e to negative 100 power can be rewritten as 1 divided by e to positive 100 power, which is huge. Denominator is huge. So 1 divided by huge number is small. Conclusion, if t goes to infinity, the e term, is very close to zero. Are you sure that you understand my explanations?
Yes. Yes. Thank you.
So, since this is close to zero, the whole thing is close to zero. Therefore, if t goes to infinity, this goes to zero, and the result follows. Did I answer your question?
Yes. Thank you.
Well, here's what we do next. So, we just observed that if t goes to infinity, p of t goes to a divided by b. Next observation. If p0 is between 0 and a over b, p of t is monotonically increasing function. Here is why. If p is between 0 and a over b, this term is positive, but note that bigger t, smaller is this e term. So if t is increasing, since this is positive, the whole term, the whole product, becomes smaller and smaller and smaller. Therefore, the whole denominator becomes smaller and smaller and smaller. So we divide AP0 by a smaller and smaller and smaller number. The result becomes bigger and bigger and bigger. So the whole thing is increasing function. You increase t, you increase the value of the whole thing. Next observation. Let us go back to our initial value problem. Let me remind you, here is our equation. Let us copy this equation over here, and next, let us take the derivative of the left-hand side and of the right-hand side. The derivative of the first derivative is the second derivative. When we take the derivative of AP, since A is a constant, A can be factored out. Conclusion, the derivative of AP is A times P prime. Similarly, in order to find the derivative of BP square, we factor the constant B out, and then to find the derivative of P square, we use the chain rule. P square prime is 2P times P prime. Here's what we do next. P prime is a common term. Factor it out. Next step. According to what is written here, P prime is equal to this. So let us replace P prime by AP minus BP squared. Done. Lastly, factor out P. Done. Here's what we do next. A minus BP is positive because P does not exceed A over B. So this term is positive. P is population. It's also positive. Conclusion, this portion is positive. However, for this portion, there are two possibilities. If P is lesser than A over 2B, this is positive, which means the second derivative of our function is positive if P is lesser than A over 2B. But the second derivative is positive means the first derivative is increasing. Similarly, this expression is negative if P is greater than A over 2B. The second derivative is negative means the first derivative is decreasing. Now we come up with the following graph. Over here means this part. The first derivative is increasing, means the graph is concave up. Starting from this point and up to A over B, the second derivative is negative, means the first derivative is decreasing. The function is concave down. Overall, the function is increasing and its values do not exceed A over B. Such a curve is called a logistic or S-shaped curve. From its shape, we conclude that the time period before population reaches half its limiting value is a period of accelerated growth. A limiting value is A over B. Half of limiting value is A over 2B. Here we have accelerated growth. After this point, the rate of growth decreases. The function is concave down and in time reaches 0. Folks, any questions here?
Professor, could you just explain that one more time, please?
Yes. So, according to what is written here, values do not exceed A over B. Moreover, values approach A over B. So, we have some limiting value. According to what is written here, function is increasing. So, indeed, we draw increasing function. Then, over here, the second derivative is positive, means function is concave up. Over here, the second derivative is negative, which means function is concave down. And the second coordinate of the inflection point is A divided by 2B. Looking at this graph, we come up with the following conclusion. The time period before population reaches half its limiting value means this number is a period of accelerated growth. Growth is increasing. After this point, the rate of growth decreases and in time reaches 0. The function is concave down. Was that a question?
Yes, sir. Thank you.
Folks, let us discuss the following example. We have 5 individuals of Paramecium. These 5 individuals were placed in a small test tube. For 6 days, the number of individuals in every tube was counted daily. The paramecium were found to increase at a rate of 230.9% per day when the numbers were low. The number of individuals increased rapidly at first and then more slowly until towards the fourth day it attained a maximum level of 375. From this data, we conclude the following. A is a rate. It's 2.309. Question is, how do we find B? Note that A divided by B is maximum level. 375 is equal to A divided by B. Therefore, B is equal to A divided by 375. This is exactly how we find B. And then we plug in everything into the formula. Here is our formula once again. We replace A here, here, and here by 2.309. P0, here we started with 5 individuals. 5 here, here, and here. We replace B by this fraction. Done. And after all simplifications, here is the formula. And if we sketch the graph of this function and compare with observed values, we will see that this formula gives us a very accurate approximation.
Professor, I have a question.
Yes.
For that 375, when we did B equals 2.309 divided by 375, like how do we know what that
Yes.
375 is in order to find B? Because I know 2.309 is A.
No,
I don't know
no.
what...
By experiment, it's written
okay.
the number of individuals increased rapidly at first,
Okay.
then more slowly, until towards the fourth day, it attained a maximum level of 375. And we know that maximum level is A over B. This is how we find B.
Okay, I see. Thank you.
Sure. Other questions?
So where did the 375 in the final equation? I thought on the topic it's 2.309 times 5. So then where does the 375 in the final equation come from?
Well, we just simplify this expression and get this. It's easy to simplify. If you multiply top and bottom by this fraction flipped, then on the top we'll get this times 375 divided by this, which gives us 375. So once again, in order to jump from here to here, multiply top and bottom by the flipped fraction by 375 divided by this.
Okay, thank you. That's where I was confused. Thank you.
Sure.